Okay, the next sheet we're going to talk about is nomenclature, and this is just basically how we're going to name things. So there's a few rules and all this stuff that you need to remember. I'm going to go over the rules first before we even look at the worksheet too much. Alright, there's a couple things you're going to need. You're going to need your polyatomic ion chart. Alright, and so let me pull that out so you guys can see exactly what that looks like. 30. Alright, this is your polyatomic ion chart. And again, remember, what this is going to give you is your polyatomic ion, poly meaning many, so you've got cations which have a positive charge, you've got anions which have a negative charge, and if you look at this, you've got something like your hydroxide group here, your nitrate group, your carbonate group, all of these, phosphate. So it's going to tell you the charge on it. Okay, so make sure you have your polyatomic ion chart. The other thing you're going to need, obviously, is your periodic table. Okay, now remember with your periodic table, this polyatomic ion chart that I'm going to provide you with, it tells you the charges on the groups, but if you go back to your polyatomic ion chart, remember, we know everything that's in group 1 has one valence electron, so it's going to lose one electron, have +1 charge. Everybody here has 2 valence electrons, it's going to lose 2, so it's going to have a +2 charge, okay? We come over to group 13, remember this is +3. Group 14 plus or minus 4, group 15 minus 3, 16 is minus 2, 17 is minus 1, and 18 is going to be your 0. Alright? And if you have questions over that because you're not sure, you need to come, probably make an appointment to see me for tutorials. Also on your polyatomic ion chart, you will see here in the middle where it says these have +2 charges. A lot of these metals are going to be your transition metals, which are in this area here. These are the ones that change, if you guys remember. We always know everything here is a +1, +2, you know, in the groups I went through over there, aside from a few, they're going to have the charges that's above their group. These right here are going to change, and so you're going to either be provided with this chart or you're going to need to memorize what some of these in here are. Alright, where's that paper go that I was writing on? Remember, for an ionic compound, this is going to be a metal plus a nonmetal. Okay? And then for covalent, these are all nonmetals. Okay? Brief overview. With your ionic compounds, remember, this is going to be a cation, which is going to have a plus charge, and your anion, which is going to have a minus charge. Alright? And so this is the case where, in these, that we're going to use the crisscross rule, which means that if I have X, which is my metal, okay, well, I don't want to use that. We have M, it's going to have an X plus charge. I have my non-metal, okay, and this is going to have like a Y minus charge. So remember, this is the case where we crisscross these, okay? So what you're going to get is you're going to get your metal with a Y and your non-metal with the X. Alright? And we'll go through a few of those so that you guys have an example. One example we can use is if you have barium, which is a 2+, we have chlorine, which is a 1-. Can you see that on the camera? Okay. When we cross these charges, we get BaCl2. The reason because barium has 2 electrons. Chlorine has 1, 2, 3, 4, 5, 6, 7. It's going to give one away, and then it still has one more, so what you need is you need another chlorine. You need another chlorine, and it'll give away this other one, which makes sense that you would have 2 chlorines for every 1 barium. Barium has 2 electrons to give. Each chlorine can only accept 1, so therefore you need 2 chlorines. Alright? Okay, so that should be your brief overview on that. Oh, one more thing with this. Your transition metals, if I say that you have something like this, copper 2 chloride. Oh, I spelled chloride wrong. Is that right? Anyway, alright, so you'd have copper 2+, Cl 1-. This 2 tells you exactly what the oxidation number is, okay? So as your oxidation number 2, Roman numerals tells you that. So again, we crisscross these and you would get copper 2 chloride. Okay? Alright, that is your brief overview, and now let's go through a couple problems. These should be fairly easy. Oh, I didn't go over the other thing with you. Okay. Let me go over this. When we're naming covalent compounds, okay? Remember with the naming of covalent, you're going to use prefixes like mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright? So if you have something like this, simple one, CO2. Again, we know that this is a covalent compound because it's nonmetal, nonmetal. Then, how many carbons are there? We would say that this is mono carbon, 2 oxygens, dioxide. Now, if mono is in the first one, we don't need to put it there. So this would be carbon dioxide. If I had something like C2H6, we would say that this is dicarbon, hexa for the 6, right? Hydride. Dried. Okay? Always remember you're changing the ending to IDE, okay? Unless it's one of your polyatomic ions, and in that case you just keep the ending as it is, okay? And we'll go through some of that with the examples, but the ending here is always going to end in IDE, okay? Don't use mono if it's the very, very first one, but if I had an example like this, which was into O, you would say that this is dinitrogen monoxide. So if it's the second one, and there's only one of them, you have to use the mono, okay? Okay, so now we can go through a few examples. I think that's your brief overview there. And again, you guys can always supplement this with any stuff you want from the book or whatnot.